Hello everyone, welcome to Ravi's Academy. I am Dr. Ravi, Professor of Mechanical Engineering. In today's class, we will be understanding the outline of kinematics of machinery. And in this, let us understand the title of the subject, kinematics of machinery. As you know, kinematics means it's motion, analysis of motion, it's motion parameters, analysis of motion of various machine elements. You are going to understand the motion parameters means it may be displacement, velocity or acceleration. So we are going to analyze in detailed manner the motion parameters of machine elements. Means you are ignoring the forces, you are just focusing only on motion parameters. So that is the reason this particular subject is also known as pure mechanisms. That means in this particular subject, you are going to understand the various types of mechanisms in by means of 6 units of syllabus of this particular subject. So let me give a brief outline of the syllabus content of kinematics of machinery. Let us look at this unit 1. In unit 1, so this particular title of the unit is mechanisms and machines. Mechanisms and machines. So in this you will be understanding the terminology of KYM subject, definitions and the basic concepts. The basic concepts of KYM you will be understanding. That means mainly you will be understanding what is meant by kinematic link, kinematic pair, kinematic chain and kinematic inversion, and kinematic inversions of various kinematic chains like 4-bar chain, single sided crank chain and double sided crank chain. You will be so mainly the nature of this particular unit is you can say it is theory. The nature of the unit is unscaled diagrams, and you are going to it is a mainly a theory part you have in this particular unit. And let us look at unit 2. So in this you have velocity and acceleration diagrams. That means you are going to draw the velocity diagrams and acceleration diagrams. As you know very well, the acceleration diagrams are important in order to calculate the inertia forces, and that is the reason you are calculating the accelerations of various links in a particular mechanism. And in this you have mainly two methods. One is relative velocity method, and the other method is instantaneous center, eye center method. So here, by means of relative velocity method, we will be drawing velocity diagrams as well as acceleration diagrams. But here, the instantaneous center method is useful only to calculate the velocities of simple mechanisms. So let us look at this particular unit. This particular unit is a totally drawing method. You are going to draw the velocity and acceleration diagrams, and it's a totally nature of the unit is problems. The nature of the unit is problems, right? And let us look at unit 3. This particular title of the unit is mechanisms with lower pairs. Mechanisms with lower pairs. In this you have steering gears, second topic is hook joint, and the third topic is straight line motion mechanisms. And you have three topics in this, all are connected with lower pairs. You are going to study in detail about the condition for the correct steering gear mechanism, and the applications of hook joint and polar velocity diagram of hook joint, and straight line motion mechanisms, exact straight line motion mechanisms, as well as approximate straight line motion mechanisms. So this is about the first part of the syllabus, unit 1, 2, 3. So this is mainly, you can see that it is mechanisms with lower pairs. The other side, you see that unit 4, in which you will be learning the cams and followers. Cams and followers. You are going to study the types of cams and followers. Apart from that, you are going to construct cam profiles with uniform velocity, uniform acceleration, and a simple harmonic motion. You have three types of cam profiles. That means the follower moves with uniform velocity, uniform acceleration, and uniform simple harmonic motion. How to design the cam profile, that you will be learning in this particular unit. Apart from that, you are going to analyze the specified specified contours of cams. The other way, that means it is you are giving the cam profile, you are designing the cam profile in the simplest way, maybe combination of circular arcs and straight lines, and after all, you are analyzing for velocity, acceleration. That's what is your specified contours. And in unit 5, in which you have toothed gears and gear trains. In toothed gears, you will be understanding, or you are deriving the expression for the length of arc of contact, path of contact, and contact ratio. That is one area. Okay, let me write length of arc of contact, length of path of contact, and contact ratio. Problems on this, derivations and problems you have. And the other side you have is derivation for the number of teeth on gear and pinion to avoid the interference of the gears. So these are the two important areas, and in this you have derivations as well as problems. And the other side, you see that toothed gears. In toothed gears, you have gear trains. You have number of types of gear trains. In this, you have a simple gear train, compound gear train, reverted gear train, and AP cyclic gear train. So these are the various types of gear trains, and you will be understanding how to calculate the train value, the velocity ratio of various types of gear trains, and the best way of calculating or having velocity ratios is epicyclic, that you are going to understand by solving the problems. And the last unit is that is unit 6th is belt, rope, and chain drives. So in this you are going to understand mainly the types of belts, that is a flat belt, V belt, and circular belt. And you will be understanding the belt tensions, driving tension, that is tight side and slack side tensions, and centrifugal tension, and finally how to calculate the power transmission. This is what exactly the outline of kinematics of machinery.